The mean absolute deviation is a measure of spread that indicates the level of variability in a data set. It is the average distance between each data value and the mean of the data. It is defined as the average of the absolute deviations of data points from the mean value of the data. The formula for mean absolute deviation for group data of the continuous series type is given by the summation of the product of all the frequencies and the absolute deviation from the first value to the nth value, all divided by the number of data values. Sigma here is the summation of the values from the first to the last. F sub I is the frequency of occurrence of each of the classes or groups. The double lines are called modulus. They present the absolute value of whatever is within it. X sub I is the mid value or midpoint of the class interval. X bar is the mean of the continuous series data, which has its own formula, and n is the total number of data values. Now let's use this formula to find the mean deviation of this data set of the ages in months of all the 14 children who attended a nutritional clinic in Samaru, Zaria in the first week of January 2025. What is the mean absolute deviation or the mean deviation from the mean of this data? Now we can see that this data is a group frequency distribution of the ages, and this data is organized using a continuous series distribution. To begin with, let us reorient the table to make it easier to compute the mean deviation. So we have the age here and then the frequency. And then we had 3 children who were aged between 0 to 9.9 months. Now remember, this is an exclusive class interval. So the upper limit of 10 months is excluded from this group. Now if you want to get a better understanding of the different types of class intervals, inclusive versus exclusive, then check out the link above or in the description of this video. So let's continue. Then there were only 2 children who were between 10 and 19.9 months old, 5 children between 20 and 29.9 months old, and 4 between 30 and 39.9 months old. So the total number of children is 3 plus 2 plus 5 plus 4, and that will be 14. Awesome. Now to apply this formula, let's first represent the data we have in this table with the proper statistical notation. Let's start with the first element in the formula. That's the frequency. So we label this as F sub I. Our total number of children, which is the sum of all the frequencies, is 14. So our n is 14. In statistics, the actual data values of the variable are usually labeled as x, and our variable here is age. However, unlike individual series data and discrete series data, we don't have information about the actual age of these children. We only have their grouped age. But we will need one value to represent the age of each class. According to the formula, we will use the midpoint of the class intervals. So let's create a new column to enter x sub I for each class. To calculate the midpoint, we will add the lower limit plus the upper limit and then divide by 2. So for this first class of 0 to 10 months, our lower limit is 0 and our upper limit is 10. So for the midpoint of this class, we will add 0 plus 10 and then divide by 2, and that will give us 5. So our x sub I for the first class is 5. Awesome. For the second class, 10 plus 20, that's 30 divided by 2, and that will give us 15. So our value here is 15. For the third class, 20 plus 30 divided by 2, that's 25. And for the last class, 30 plus 40, that's 70 divided by 2, and that's 35. So we have our f sub I, our n, and now our x sub I. What is left to complete this formula is the x bar, which is the mean of the data. Now to find the mean for a continuous series data, it is given by the sum of the product of each of the frequencies and the corresponding class midpoints, all divided by the number of data values, which is n. So let's add another column for multiplying the frequencies and the corresponding class midpoints. We will call this f of x. That's the frequency multiplied by the x. Now what we need to do for each data value is to multiply it by its corresponding frequency to get the f of x. So for the first class, we will multiply the frequency of 3 and the midpoint, which is 5, and thus we would have 15. For the second class, we'll multiply the frequency of 2 and the midpoint, which is 15, and we would have 30. For the third class, we'll multiply the frequency of 5 and the midpoint of 25, thus we would have 125. And for the last class, we'll multiply the frequency of 4 and the midpoint of 35, thus we would have 140. And our total will be 15 plus 30 plus 125 plus 140, so we'll have a total of 310. So the summation of f of x is 310. So we already have the numerator of this formula as 310, and then we'll divide by the number of data values, that is n, and we know n is equal to 14, right? So 310 divided by 14, that's 22.14. So our mean, that's the x bar, is 22.14 months. Alright, so now that we have all the elements of the formula, let's break the numerator of the formula down to make it easier to compute. Let's first find the absolute distance between each class midpoints from the mean. That's the modulus x sub I minus x bar part of this formula. So let's add it to the next column. For the first class, the absolute deviation of its midpoint from the mean will be 5 minus 22.14, that's minus 17.14. And when we apply the modulus, the absolute value is 17.14. Awesome. For the second class, it will be 15 minus 22.14, that's minus 7.14, and so the absolute value is 7.14. Then, for the third class, we will have 25 minus 22.14, and that will be 2.86, and the absolute value is 2.86. And for the last class, we will have 35 minus 22.14, and that will be 12.86 with an absolute value of 12.86. And we don't have any use for the sum of absolute deviation, so we'll leave here blank. Now that we have all the absolute deviations from the mean, the next thing according to the formula will be to multiply each of the frequencies with the absolute deviations. So let's add another column. Here we will label it f sub I multiplied by the absolute deviations. So for the first class, we have a frequency of 3 and an absolute deviation of 17.14. So 3 times 17.14, that's equal to 51.4. Then for the second, 2 times 7.14, that's 14.3. Then 5 times 2.86, that's 14.3 again. And lastly, 4 times 12.86, and that's 51.4. Awesome. And if we add all these together, we will have 51.4 plus 14.3 plus 14.3 plus 51.4, giving us 131.4. And if you noticed, at this point, we already have the numerator of our formula. That's the sum of the product of each frequency and the absolute deviations of each value from the mean. Great. So the last thing we need to do now, according to the formula, is to divide this by the number of data values, or n. So we'll have 131.4 divided by 14, which will give a mean absolute deviation of 9.4 months. Awesome. So what does a mean of 22.14 months and a mean absolute deviation of 9.4 months tell us about our data on the ages of children in the nutritional clinic? Well, a mean of 22 months indicates that on average, the values in our data set tend to be around 22 months. And the mean absolute deviation of 9 months suggests that the typical difference between each child's age and the mean is 9 months. In other words, while the average age of children that were attended to in the clinic was 22 months, the individual ages of the children deviate from the mean by 9 months on average. Easy peasy. So this is how to compute the mean absolute deviation for continuous series data. Now, if you want to learn how to calculate the mean absolute deviation for ungrouped data, check out this video here. And for discrete series data, check out this video right here. And don't forget to like, share, and subscribe for more easy statistical videos like this. And as always, thanks for watching.